how many of you feel, let's get a show of hands, I got a lot to learn on brood diseases. I don't understand them. They pop up, I don't know what they are. Okay, how many of you feel like the major brood diseases, I could identify them. When I see them, I know them. There's obviously shades of gray out there. Thank you. So there's our resource, and you can please chime in as we go along. Oh, and the mic. Is that better? Yes, okay. This is the crash course on brood diseases. I want you by the end of the day, end of the evening, you should be able to diagnose the major brood diseases. Feel like you know where to go, know the key symptoms. I also want you to be able to understand the cycle and where to intervene and how you can, I'm going to give you 7 techniques for brood diseases. To begin with, let's all play a game. What is normal brood look like? What do we have here, folks? Larva, right? And you can see the eggs there as well. There you can see the eggs. There are the larvae floating in brood food. I'm always, when I work with native bees, I'm always, brood food is not a thing in native bees. You roll a bunch of pollen up and you lay an egg on it. There's none of this goopy stuff. It's always a transition to come back to honeybees. But is there any problems here?
No.
That looks good, doesn't it? Okay. You see that thing sticking up?
Yeah.
That's the egg there.
Huh? That like that shiny looking thing?
Yeah, the shiny looking thing. There's one egg there, one egg there, one egg there, one egg there, one. The queens, you can tell this is a newly laid egg, as the queen has a gland. A lot of bees have this gland called the Duffer's gland that puts a little glue on that egg. And on day 1 it's upright, and by day, just before the larva emerges, it lays flat. So you can even age the eggs. Okay, yes, you can see here, I want you to notice, here's some brood that's sealed, and here's some brood, you can see it's just getting sealed up. What do you notice about that larva? What is its orientation?
Flat in the bottom of the cell?
Not really, it's in a C shape. You see it? Yeah, it's in a C shape yet. And I want you to pay attention to this because a lot of the brood diseases kill the larva at this transition from when it's in a C shape to where, as you point out, it starts to lay flat. And that is diagnostic. Where is it dead? Is it dead in a C shape? Or has the larva laid flat on the cell, as she will in a couple of days under that capping? So here we've got our honey. There's some pollen, there's some honey. There's a larva being capped. You can see the fresh, we're going to talk about holes in cells, and you can see this is a hole, obviously, but it's one that's going to close. It's normal. There's fresh wax on the edges. This is normal. Just to remind you from the old textbook, egg goes there, you've got 5 instars, and look what happens after the capping. You see, it's in a C-shaped, and then it does a flip. And then if you look at it inside section, it lays flat, where it spins its cocoon, undergoes pupation, and you have an adult. But look at the difference between that and that, laying flat and in a C shape. This is going to be key to the brood diseases. What do we see here? Does this look normal?
Yeah.
Yes.
Yeah.
Why is it normal?
Nice tight brood pattern.
Textbook.
Textbook, and I like this answer. It's a tight brood pattern. This is sealed brood here, and you can see there are a few holes, but that's normal. There's always going to be a few holes in a brood nest after the queen is laid and everything gets capped up. It usually looks solid like that. Who here is brand new, hasn't kept bees before? Okay, look, there's caps here. You see that? That's capped honey. You can see the difference with the capped brood. It's a kind of regular dome shape as opposed to this, which is kind of like wriggly. That's the capped honey. If we took our finger under there, the honey would dribble out. So there's going to be occasionally a hole. 1 or 2 holes. There's always normally a hole after everything gets capped up. Now, let's look at these pictures. What you're going to do if you're going to look for a brood disease, I will tell you this is not the way to do it. But let's just start here. You pull the frame out, there's brood on it, you're trying to look for a problem. Let's say you shake the bees off, and you'll learn if you're new how to do this. You just use your wrists with into the box, you shake the bees off, and it exposes the brood for you to see, and you see this. There's a big hole here. Is this a problem?
Not really.
Could be. Who said could be? Yeah, what could be the problem?
Could be
Something could be going on. Yes, something could be going on. Is there any others out here? Yeah.
I just have a question.
Yeah.
When the bees start capping off
Yeah.
cells,
Yeah.
do they start in the middle and then go out, or do they like start from the sides and go in? Like how does that work?
It typically starts from the middle and goes outwards. Yeah. So that kind of gets us to where we're going.
Yeah. Okay.
The hole in the middle here, you can see there's a bee starting to chew out there, and there's a bee starting to chew out there. This is, you could imagine it, a progression. The queen lays an egg, they get mature, the ones in the center are older, and then these start to emerge. If we came back here the next day, this hole will get bigger and bigger until it's all gone. This is totally normal. Getting a big hole in the center of your brood pattern, this is normal. We're all good?
Yep.
So I'm assuming if they lay in the middle and then go out, then I'm assuming that the larvae in the middle are going to get older quicker, so it's going to go hatching from the middle.
Yes.
Right. Okay.
So yeah, and she'll likely come in here and start laying eggs, and so you can see this pattern recurring.
Okay.
Yeah. So there's emerging brood. This is brood set to emerge, and just to remember, this is the honey along the top. How about this? Is this a brood disease?
Yeah, looks like mold.
Okay, who said no in the back there? Yes, what is it?
It's just mold.
It's just mold. What happens, you'll see this in the spring, it is not a brood disease, it has nothing to do with brood. The adult bees, sometimes a colony will die and they'll run out of food, for example. Feed your bees lots of food in the month of October until now. Get lots of syrup. If they die, the bees are trapped, the moisture gets trapped, and you'll get a little residue of fungus growing around there. And that's normal. You can actually give this back to a colony and they will clean it up. This is not a brood disease. Looks gross, but it's not a brood disease. And here it is. You can see here the bees all died because they ran out of food, and then they just kind of mold over. No problem. How about this?
How long does it take to clean the mold from a?
Not long. I never checked. Anybody know how long it takes to clean a moldy frame up?
Couple days, not very long.
It's pretty quick.
Does it look like pretty normal from before? Like it got moldy? Like does it like look like it's totally back to normal after they clean it?
Yes.
Okay.
It's just on the surface. Yeah. Okay, what about this?
Very spotty.
Doesn't look good, does it?
No.
Spotty, I heard. It's not that contiguous pattern. I will say sometimes early in the spring, your first brood patterns don't look good. The bees are old. Like I'm talking, if you open a colony in March and look at the brood pattern, the bees are old. They can't feed very well. They're having trouble regulating the nest temperature, and sometimes it can look patchy. But if you go in as the season progresses and you see this, this is a tip to you that there's a problem. So you're going to look more carefully. So as you're looking through your brood nest, you see something like this, you're going to stop and start to look more closely. Now, here are two people looking at looking for brood diseases. So you pause, and now you're going to go through all of the brood frames looking for problems. And I want to just, how does this go then? Yes. And so the brood diseases that you are concerned about are 4. two diseases called foul brood, chalk brood, and sac brood. Let's talk about American foul brood, likely the most destructive disease that you will encounter. It is highly contagious. It persists on old equipment for a long time, and it means buying old equipment always has a risk of having this disease. So here we are. This colony has American foul brood disease. What did we just notice here?
Very patchy.
Very patchy brood. So that stopped us right away to go look closer. And you look at the next frame and the same thing. It's not a one-off. Every frame is starting to look bad like this. And the other thing you notice is that the cells have holes in them, but they're not those normal holes that are just of being sealed up. They're ragged. The bees are picking at the brood. Here you can see it. Look at the jet. Remember that cell that was being closed up? It was nice and round around it. Look at the edges here. They're all choppy and broken apart. If we look a little bit closer, we see some of these larvae that are laying down, and they are coffee colored. And when you look at the bottoms of the cells, you start to notice something. Look at this carefully. If you have kept bees for any amount of time, you know when you look at the bottom of the cell from the top bar down, you don't see all of this stuff sticking up. You see it? This one's a little bit brown and goopier. This one's kind of hard. What we're seeing is a larva that's been infected with the bacteria that is drying down into a hard, like when your nose gets crusty after a cold. It turns into that. It's gone from a very runny, full larva into something that's starting to decompose into what we call a scale. It's like a hardened piece of larva on the bottom of the cell. And you only really ever see it from this angle. If you're looking straight on, you may miss it, so you have to look at it from the right angle and get the sun on your back. Here it is, that scale against white comb. It's pretty obvious, isn't it? Here it is on dark comb. Not so obvious. So the best way to view this brood disease is not like this bozo who is me, but this gentleman here who's holding the frame from the bottom so that his eye can catch the bottoms of the cell. So what he's looking at is, here's this disease larva, right? It looked like this to start with. It starts decomposing, and then it becomes this, what we call this scale on the bottom. The only way you're going to see it is if your eye is catching this edge. So you're looking down on the frames. And if you're buying equipment, do not, and you're a beginner, this is why you're in the club. Get somebody who's more experienced to come with you and look at all the comb. You want to look for this. The disease cycle starts innocently enough. Somehow the spores enter the colony, and I will tell you, the way that the spores get in most certainly is on comb. Sometimes bees from a disease colony can drift to another. I don't actually think there's good evidence that diseases start that way. I think the major way this disease starts is you buy diseased comb and you put your bees on it. So what happens then? The worker bees clean those cells up. And what do we know about the sequence of events of a worker bee? She is born. What is the first thing she does?
She's a cleaner.
Cleans the cells out. That's her first job. What's her next job?
Nurse.
Nursing. So she's contaminated all her mouth parts with the disease-causing part of this bacteria, which is a spore. It used to be thought to be very closely related to anthrax, which also can sit on the grass for decades. It's a very resilient stage, and the bees get it on their mouth parts. They nurse the bee, and then suddenly you can see the healthy one on the top and the diseased one on the bottom. It starts to melt, and if it dies after pupation, it might even have a little tongue sticking up. But you can see there the bees know there's something wrong, and they start pecking at the cell. They uncap it, it starts to dry down into a scale, and then unfortunately another new bee comes along, scrapes it off the bottom of the cell, and in the process contaminates herself and spreads the disease around. And this cycle very rarely stops. It almost invariably brings the colony down. Now, there is a stage here when it's growing inside the body of the bee, and I will talk later about antibiotics. The idea behind antibiotics is that for a generation where that antibiotic is being administered, the bacteria can't grow in the larva because they've got lots of antibiotic in their body, and that breaks the cycle. As I will show, there's plenty of evidence to show that the disease always recurs. Antibiotics are often not a great way to treat a colony. So here you can see she's going in, she's going to clean that cell out. She doesn't know that she's not doing a good, a good deed. And I've done this before where I've put the spores, I've fed them artificially to larvae. So I have some first instar larvae and I sprayed them on the comb, and you can see here's the patch that was inoculated, and about 3 weeks later you start to see the larva starting to break down. The key thing here is that in the first week after capping, oftentimes you don't see a problem. This leads to this misconception that if you have a disease frame and you have a frame that doesn't seem to have disease, that maybe that frame is okay, and if you just took the diseased one away, the colony will recover. Oftentimes it's very young larva that still hasn't developed the disease to an extent that the bees start picking it out. Because why do we see these holes? It's because the bees have started to remove them. And early on they have the disease, like newly capped larvae, but the bees haven't figured it out yet. Okay, let's go over the symptoms. So you're going to look through the colony, you're going to look for patchy stuff. And then you're going to look for these cells that are sunken. They're not dome-like, they're sunken in, they're raggedy and open. You're then going to go in with a toothpick and kind of pick at some of these. If they're freshly killed, you can put, they have this viscosity to them that other disease larvae don't. All the rest of the disease larvae usually tumble out or just collapse into a puddle. But this one, when you probe it at this stage, it's thick like molasses. And you can actually, what will happen is, as you draw your little blade of grass or toothpick away, it will string out. It's very viscous. The brood is always going to die after the larva is laid flat, so it's never in a kind of C shape. It's always flat on the bottom, and it dies after the cells are sealed. This condition of the thickness is called ropiness. And that ropey cell, in about 3 to 5 days, will dry down into a scale. So the scale is a dried down ropey larva. How do you confirm this? Well, when you don't have a federal shutdown and your federal bee lab is in risk of being closed, you could take a sample like this, cut it out, and of course this is in the day of non-plastic foundation. You kind of take a chunk as best you can of that comb out. You can send it to the OSU bee lab, put your name and contact information, where it was and the date. And after you're done, you'll wrap it up in newspaper, not in a plastic bag where it gets, it can get all moldy. You want it to breathe a little bit. You'll disinfect your hive tools and glove, and then I would move that colony to an isolated location until you have confirmation of what it is. And yeah, this is not a useful slide right now. Yes?
What about the smell? Yeah.
Yeah, the smell, I have kind of put the smell a little bit backwards because it smells, but there are all sorts of smells in a colony, and until you smelled it, it's hard to describe. There are all these descriptions. It's a glue pot odor. I can smell it. It is a very distinctive smell. I just don't know how to describe it. And
Brood stinks when it dies. So there's a lot of times where brood might die and it's going to have a smell to it.
Yes.
But what I've heard from the people that I know that have experienced is that this is pretty severe, where you would have to, like with EFB or some of the others, you would have to open the hive and be holding something to smell it. And I don't know because I've never had it, but people that I've known that have had it have said you can smell this when you're in the apiary and not even having the hives open.
Yeah, that's a little bit of an overestimation. I've worked a lot with American foul brood, but you can, when you open the lid, smell it. I just worry about it because there's all sorts of smells for a beginner that you smell when you open a colony. Pollen smells, but it does have a distinctive smell. I would really...
Smell like dead animals, what I've heard. And it smells like dead, but...
No, it doesn't smell like dead mice, and like it doesn't. It has a smell that's kind of like I can smell it in my nose, but I can't describe it.
Like crabs in the summer.
Oh, maybe. It's not an unpleasant odor. Put it that way.
Oh.
The way that it's described is like the glue pot, but who has a glue pot these days? It has this smell that is distinctive. But I will say at low levels of the disease, you won't smell it.
Okay, good to know.
When you get to what I'm showing you here, you definitely will. And it has a distinctive smell. And so maybe the thing to point out is that it will have an odor if it's bad. And it will be an odor that is different from other odors that you smelled in the colony.
Does it smell different than EFB in your opinion? Because
Oh, yeah.
stinks. To me, I can smell EFB when I'm in a hive.
No, it has a real distinctive smell, and I think the reason for this, if I can just nerd out with you for a bit, this bacteria, one of the old tests for it, you can probably still find it online, is the Holt's milk test. You take dried milk and you put the scale in it, and it will clear it very quickly. And I think the reason is because this bacteria has high levels of this enzyme that digests protein, proteases. That's why it will clear the skim milk. And my sense is it's just this kind of smell of decomposing larva, but it's a different kind of decomposing larva than other smells.
Okay.
If that's...
That's very awesome to hear that. I mean, that makes a lot of sense. Weird.
Okay. But they do have these tests, which I believe are still back out of stock. I think the EFB test kits are out. It's hard to find them. But it's a COVID test kind of thing where you take the larva, you smear it up. It's pretty good. It works really well. And you have a control line, and if it's positive, you'll get 2 lines. And you just crush the larva up. You put a couple drops here. And it's got this little beads that you shake around for 30 seconds that crushes the larva for you, and it's very accurate. Questions about EFB? American foul brood, which we also call AFB.
How common is it?
It can be, there was an outbreak, if some of you who are in this for a while, there was an outbreak in the Portland area recently, and it's common when, again, equipment is distributed. I think in this case, there was somebody who was selling nukes who had a problem, and then it went everywhere. So it's in those kinds of situations where it can get pretty common. But I'd say in most cases, if you are starting with your own equipment and you don't really buy outside equipment, you likely will not see this disease. The risk goes up as soon as you're buying equipment. And I would say brood frames particularly, you put yourself at risk. Yeah.
Is there any great danger in like catching wild swarm or whatever and then bringing it in?
I'm going to say no, and I'll tell you why in a bit. There's an actual treatment for American foul brood that goes back to the Civil War, where you take an infected colony and you shake the bees onto foundation, and the disease disappears. So my sense is swarms are not a huge risk.
What do you mean by foundation?
I'll show you.
Okay.
Yeah, it's coming up.
Okay.
And then you're supposed to burn your hives, correct? And then Oregon has a replacement for your colonies if you have, you're registered through the state, right?
No.
That'd be awesome.
It used to be the case. It used to be on the books as most of the states had it as a disease that the state apiarist would have to come and destroy your colonies. That has lapsed. It's not an Oregon statute anymore. So you could technically just be irresponsible and do something with it. But yeah, there's no requirement to destroy it. But if you were prudent, that's what I would do. I would destroy the colony. Yeah. Pour some gasoline into it. Kill the bees with the gasoline vapors. Put it in a barrel. When there's no burn restriction, the gasoline will help and it'll dissolve.
And just so everybody knows that if you have painted gear, you have to have a permit to do that. But we actually have one on file through the club with Tom Sinclini and
I didn't know
a couple
that.
other people offered us their permit that they can have up to a certain amount of people on it. So if anybody ever comes up against this and you need to burn stuff and you're like in a neighborhood or you're afraid to how and what to do it, we have the paperwork that Tom sent over. And
Fantastic.
yeah.
Okay, great. Yes.
If you're buying used stuff, is there any way to mitigate or like sterilize before you use it, or just don't buy used stuff?
Okay, so there's the lowest risk is if you're buying honeycomb. Drawn honeycomb is, I think the risk is extremely low. Brood comb is tricky. And the only way to deal with brood comb is something that is not an option out here. That's irradiation. And so I know in British Columbia and Vancouver, they have a facility that does electron beam radiation for comb sterilization, but we don't have one anywhere on the US West Coast.
What about just for like the wood equipment? Heat or?
Yeah, I'll talk about this later on, but the wood equipment I think is of less risk, and a tiger torch on the interior, scorching the inside and getting rid of all the wax is one way to deal with it. You will have sooty hands for a decade later, but it does work. Okay. European foul brood. This is I don't have any new data, but this is the Sagili lab is working on this. It's got a large project with multiple labs across the western US. So you'll have more from Dr. Sagili as we go on. But I want to point out this is a graph from the USDA honeybee lab in Beltsville, which is slated to be closed, folks. And you could send your samples there and they would identify them. The orange is, this is 1984. 1984, you can see of the samples that were sent in, a high percentage of them were American foul brood. This is comb that was sent to them. Look what happens to the American foul brood. It starts to go down, and the blue is European foul brood, and it is on the rise. There is a trend towards European foul brood becoming a lot more common over the last decade. The disease is weirder. It's a weird disease. Nobody quite understands it. Here we've got a healthy larva. It goes, it develops. It has bacteria in its gut, good bacteria. You'll hear about the good bacteria. You eat your yogurt and all that stuff. And it caps, and you have a normal pupa, and out it comes as an adult. So with European foul brood, it gets infected with this bacteria that gets into the gut. Sometimes depending on how well it's fed, it will go through the C shape, and just as it's laying flat, it starts to die. And so you get a kind of corkscrew, it's like not fully C shape and not fully flat kind of symptom. Sometimes it does go in step 2, it does actually, there's enough food to keep the bee to go to adulthood, but it's a small bee because it's been starved, because the bacteria is competing for food with the larva, and you get these tiny little bees that pop out. But oftentimes when there's not enough food for both the larva and the bacteria, it kills it, and you get these kind of corkscrewy type of symptomologies. And the weird thing is, because there's different bacteria in a colony, the symptoms can sometimes vary. Because what happens is this bacteria is thought to starve the larva to death, and then the vultures come in and take over. And depending on which vultures, i.e. bacteria, are there, the disease symptoms look a little different. It is thought to, we have some evidence of this, I'll show you some data that I produced, be associated in commercial colonies with blueberries. Now, it's unclear if it's because it's blueberry season or something about blueberries. The verdict is open and there's data that's coming in, and I'll tell you the early glimpses, it doesn't look like it's just blueberries. Here's an example of it. You have this larva. Look, you see this one is doing somersaults. It's upside down and backwards. This one's going sideways. This one, you're seeing larvae in all sorts of contortions in the cell. Remember, the American foulbrood was clear as a bell, flat and black. Here it's like this one's gray, this one's white. It has a variety of symptoms. The only thing about it is in some kind of contortion between C-shape and laying flat. Here's what we saw in blueberries. It really does erupt in May, June. It says 2019 and 2020. I graded a number of 4 different commercial beekeepers. You can see the severity index, 3 means like more than 50 larvae. When they come into blueberries, only 4 of the colonies have EFB, but by the time they leave, it's quite high. And the same thing in 2020. Only 1 colony had EFB at the beginning of blueberries in April, but by the time they left, only very few of them still were disease-free. Most of them erupted with a disease. And it has an impact. This is a study I'm going to show you from Michigan. If you looked at the colonies, the strength of the colonies by looking at the number of frames that are occupied, right? So this is 1, 2, 3, 4.5, let's say, frames occupied. If you went back and did this after blueberries, you get a sense of the growth of the colony. Healthy colonies after blueberry in Michigan had about 0.5 more frame edges of bees after blueberries. If they had EFB, they barely grew. So it really slows the growth of the colonies down when they get this disease. One of the ideas about this disease, which I've already hinted at, is the way the disease works is why it has this kind of seasonal character to it, is that when there's more food per larva, there's higher survival of the larva. The bee goes to pupation, it poops, and the disease is thought to spread. If a bee poops, then all that bacteria comes out. It's thought that when there's less food per larva in the colony, there's lower larval survival, and so the disease declines because the larva never gets to the pupation and never defecates. I lost you all. The gist of this is that the disease seems to appear shortly after an intense flow of pollen and nectar. So the idea is that the disease starts to erupt and you see the problems when the colony has too many mouths to feed and there's a lot of dead larvae. But a lot of dead larvae is actually a good thing because it means the colony is going to start to recover. Here's an example. So here's the main nectar flow in Britain. This is an old data set. You can see the disease goes up and up and up. This is larva and pupa, I believe, this is the larva and pupa in the colony. It's growing, and as the colony hits a peak, the disease starts to decline. And I guess the idea here is that as you get a lot more bees and the flow kind of starts to curtail, the bees start to die early. And when they die early, they throw them out and the disease cycle is cut. You can see this in the historic data set of samples sent to the Beltsville Bee Lab. If you look at American foul brood, it sort of starts in the spring and just continues through. But the samples that were collected in May, June, and July of EFB, they get a lot more of them at those months. It really sort of seems to erupt and then come back. But what I'm really concerned with you, how it works and what's going on with this disease, maybe not less important than you being able to identify it. Here are the two diseases from this old USDA publication. American foul brood is going to die when it's flat on the cell. And it's going to, turn into a puddle and then a scale. Look at this here. It's going to die as it's laying flat. You're going to have contorted larvae. If it does dry to a scale, it's going to be at a bit of what they call a corkscrew. The other thing is, here you can see some of this corkscrewing as well. Because there's this intense bacterial activity happening in the gut, it often has a fried egg appearance, that like a little yolk in the middle. Like there seems to be an intense yellow color in the center of the larva. Here you can see it again, classic kind of riding up the side of the cell. It's already decomposed, and there's that kind of very inflamed gut with its very bright yellow. It does sometimes, not frequently, dry to a scale. I think that they're good at taking it out. And the scales are not going to be flat, they're going to be kind of twisted in the cell. Here's some other examples. Look at how it's kind of like, it's not laying flat. And here's some advanced symptoms, some going up the side of the wall, all sorts of directions. To recap, it's going to lay twisted in the cell. The scale, or the larva, is easy to remove. If you poke your stick into that larva, it's just kind of like a fillet of fish. It just kind of like, comes apart. It's not like a goopy thing comes out. The symptoms appear to have a seasonal cue to them. The theory is that when colonies have a lot of brood and suddenly the food kind of curtails, that's when the disease erupts. And it is thought that the disease starts to decline, leave the colony as the disease erupts. There is evidence that's coming out from OSU and other labs that we have a new strain in the Pacific Northwest that may be changing the narrative on that. Stay tuned for the next time Dr. Sagili or Carolyn Breeze come down. Any questions about this puzzling disease? Yes?
So when you say that the disease declines through the season, does that mean a colony will recover, or is it pretty much still a lost case?
It depends. And there are some colonies that we've been tracking. We tracked about 1,000 colonies over the last 2 years from multiple states. Some colonies do recover. Some colonies don't. We've also learned that the disease is much earlier. We have seen eruptions of it in almonds, and then it goes away. Then you come to blueberries, as you saw here, and suddenly the disease has disappeared again, and then it pops up. So it has this kind of quality that it's still there. It's still in the colony. I think this idea that the disease completely clears up may not be as we thought it was. Yes?
Is there evidence that colonies recover when you feed them pollen or sugar, or which one of those? For one thing, do they recover at all from being fed artificially? Which one of those would be the active?
It makes sense. Like if you feed them, then maybe that, it's a nutritional disease. Maybe it kind of helps with things. There have been numerous people who've thought the same thing and done pollen patty studies, and none of the pollen patty studies seem to bear out. So unclear at this point. Yeah.
So just to give a little background, like 2 years ago, I had like almost my whole operation devastated.
Oh no.
And it was really, really bad. And what happened was, for me, was it was nutritional. I made my nukes really early that year,
Yeah.
and it got cold. and they were very highly populated nukes, and they came back, they had mated queens. I fed them a whole bunch and thought I was like, and they looked better for a little while. But then later on in the fall, when the food started getting low again, they just busted out with all of these symptoms.
Oh, no.
And they were all the babies. The ones that had it the worst were all the little ones that I had made earlier on that showed signs of it in the early spring when the weather got bad and there wasn't, you know, they had all these mouths to feed and they were doing this whole thing and tons of brood in them. So what I'm curious about is there any evidence that has come out about this sort of like it being dormant and like, you know, like nutrition gets better and the weather gets better and they sort of look good, and then a little stress comes along and then they flare up with it again.
Great minds think alike. I've been arguing in the lab meetings. We have these adult bee samples. There's no brood for a period. And I do think we take our last samples are happening now. We're doing our last sample on the way to the OSP. You should go to the Oregon State Beekeepers Association meeting, even though there's going to be a snowstorm. Please go. But we're going to do our last sample. We have Tom's bees are over over on that side. I think those colonies with high amounts of bacteria in the adult's guts, I think it's residing there, are likely to recur the next year. I think there's a reservoir, and I think the adults are the reservoir. I don't know. We got the samples to do it. Like
Yeah.
we can look at it.
I had to get real farmery and coal hard, and it wasn't until I culled them out and really took out the ones that had that. The other question I have is there any evidence that the drones spread it?
Oh, no, I've never heard that one.
And then the other third one is there's a big rumor going around native bee groups that the honeybees are spreading it to the bumblebees and the native bees. Is there any evidence about that?
So I was going to say, yeah, no, that's hooey. But there is, European foul brood is the one bacterial disease that has been showing up in samples. But as I love to point out to the native bee zealots, I'm one of them. But just because you show something doesn't mean it has an impact.
Right.
You can detect anything with these tools. Even if it's in that bee population, is it reproducing in it? 2. And the third is, how do you know it's not going one way or the other?
Right, right.
There's all sorts of uncertainty, and I think people are quick to jump to conclusions because of their prejudices, but I don't think there's good evidence that it's having an impact.
That's what I was wondering. Where are all the stories of, like, because we can testify that it does kill our colonies or they just don't grow, which is what we've seen a lot. But is there any information being like, we've had some native bee die-offs because of ESB?
No. It's detected. It's been detected in all sorts of, in even wasps. What it means, who knows? But it has been detected. Okay. Chalk brood. Chalk brood was not always a disease that we had. It was first reported in the 70s. In late June 1971, a sample of dead bee larvae of honeybees was sent for diagnosis at the USDA lab in Laramie. That's a long time ago. By a commercial beekeeper in Nebraska. And then it describes it right here. This is the disease. The disease colonies were very slow in increasing their populations. The dead larvae were dried and had a somewhat spongy consistency. Most were chalky white on the dorsal surface and mottled with light brown on the ventral surface. A few were covered with black spots. Looking at it under the microscope, we saw masses of fungal mycelia. It's a fungus. Okay, so this disease that every beekeeper who's been keeping bees for a year or two knows, because it's everywhere, wasn't always in North America. It showed up in the 70s. It's got this very distinctive thing. When it kills the larva, here it is killing the larva fills the cell. Remember all the other ones, they sink or they collapse or they're It's laying flat on the cell and it fills the cell up. You can see it's a fungus. Here we are growing it on media. They're eating spores and it just kind of turns into a fuzzy thing. Here's the larva just starting to develop. It's starting to break through its body with those little fungal hyphae. And that's what it looks like. You'll see it. It breaks out everywhere. Everybody's got it. I don't know anybody who doesn't have it. From time to time it'll pop up. And notice it fills the whole cell. And if you look at the head, it's got this peculiar little, like, tiny head. It's got this, and it can also turn black if the two opposite strains of the fungus come together. It forms a black color. And you're going to see it on the bottom boards first. I think if you're taking the journey level test at Master Beekeepers, this is the one thing that will nick you on. Did you look for chalk brood on the bottom board? So there it is, chalk brood. You see it? It's just real chalky. Again, it comes in a black and a white form, but look at the head. The head gets shriveled up into this little tiny mini head. And if you look deep down, there are these big balls that are full of spores. The spores go everywhere. Now, there has been work on this, and it's clear that this disease, I would say that everybody is going to get these spores in their colony. You're just going to happen. But you won't see it. It's triggered by low temperatures of the brood. So here you can see, if you chill the brood at, sorry, these are in Canadian temperatures, 18 and 35. 35 is hive temperature. You see you get only about 20% of the larvae are mummified if you cool the brood before the cell is sealed.
For anyone who's wondering, it's 64 degrees in freedom units.
Freedom units! Yay! Okay, but if you chill it, it's a little less than that, 25, which is room temperature. After the cell is sealed, it just explodes with chalk brood. So here's hive temperature. You still have all those spores floating around. You don't see the disease at all. But if you take a frame of sealed brood and chill it for just a short period of time, the disease erupts. Why would a frame inside a colony be chilled?
Because it rains.
Inspections.
Rains, inspections. Inspections is a good one, but
Not enough bees to circulate the temperature?
yes, low population. If you're making splits, and you'll learn how to do this in the bee club, and the splits are uneven and there's not enough workers and too much brood, it will erupt with chalk brood. Okay, they did this study here, another block of text. 3 groups of honeybee colonies were on foundation. One was inoculated with the suspension of the spores, so they put the spores on them. They removed some of the workers to decrease the ratio of adult to brood, so that was the second treatment. So they sprayed them. They also took away some of the adults, and the combination of 2. All groups of treated colonies had significantly higher chalk brood. The results indicated that at least 2 factors contribute to the disease: taking adult workers away that chill the brood and the spores. Chalk brood. Solid mummy fills the cells. Spores are almost always around and is expressed when the colony is chilled. Sac brood looks like American foul brood. It's the one that you're going to be confused with the most. It kills at the exact same stage. So it's when the cell is, larva has laid down. Sac brood will appear, is very common, doesn't really impact colonies all that much, but it can be confusing. The thing about it is, unlike American foul brood, when it dies, it's just a watery sac. So here it is. You can see it's also white, typically white. And oftentimes you'll see a frame, there'll be all sorts of uncapped sac brood larvae. It's caused by a virus, not a bacteria. And it has a kind of like sacky, this outer sac of the larva is good, it's just full of fluid, so if you puncture it, it just kind of leaks.
Can you repeat that?
Yeah, it's really a sac, it's like a Ziploc bag full of moisture. So with American foul brood, what's that?
The larva?
Yeah.
Okay.
If you poke it, it'll just kind of leak out. With American foul brood, it's going to be nice and thick and runny. And I would say it's one of these diseases that appears and goes away, appears and goes away. It really is super transitory, and not one that you really need to worry that much about, but it's one that you might get confused with American foul brood.
So, as far as chalk brood goes, is chalk brood something that you would consider don't even bother trying to treat it because it's just going to come and go?
With all of these diseases, they can have impacts on the colonies, and I will slip you the $5 bill because we're going to now talk about how to manage them. And
Let's
let's do it. Okay, there are some disease-specific solutions, and antibiotics are the one. So antibiotics are used to treat American foul brood and European foul brood. You can't just get the antibiotic, you have to get a vet to come inspect your colonies and get a relationship with you before they'll write you a prescription. Does Lane County have a vet?
We did have one, but I'm not sure. We have to probably reach out to them again and see if she's still in the area.
Vets don't like doing this.
Yeah, she didn't. She was a trainer too. She was in training, like she had just gotten her thing, and so she was all. But she was a beekeeper. That's how we got. Depends. I don't know.
So, anyways, you can't just buy it at the store. You're going to have to get a prescription.
Isn't there a state website? There should be a state website,
Yeah.
vets who are willing to work with you on
This I don't know. Thanks.
I don't know.
Yeah. Do you know?
No, you can get oxytetracycline now.
Well, okay, you can see it in the magazines, right? You can go to Man Lake and it says oxytetracycline has these products. They won't ship it to you until you.
For other people, for other animals, you can get.
Yes, that you could, if you have oxytetracycline for your other animals, you could illegally
Right.
administer it to your bees.
Dosage and all that stuff.
Exactly. Yes. Nudge, nudge, wink, wink.
Yeah.
Yeah. So that, but that is not legal. Right now, to do this legally, you have to get a vet. A vet has to make come visit you. Yes.
Well, I'm just wondering who's policing that? Like,
They
who's
just
the
can't recommend
vet police for honeybees?
So I don't know if there's a vet police.
Well, I mean, it's,
No, but who's policing it? I think it is a federal jurisdiction. I think with pesticides, it's ODA, and when it comes to antibiotics, I don't know if ODA also is the police for that. And the idea here is that you meet the vet, and they come talk to you and say, "I don't know anything about bee diseases. Can you? Are you a competent beekeeper? Can you show me the disease?" What I've heard typically happens after that is that since after you've established the relationship, you can just say, I got it again, can I get some antibiotic? And they won't come and do the inspection. But it's really at the discretion of the veterinarian. I also want to point out that there's problems with the antibiotics. So this is again from the USDA bee lab, which may not exist soon. And you can see here, when they take those samples that are sent into the lab, they streak them on a plate and they put a little bit of antibiotic in the middle, and the antibiotic seeps out, and the distance from that disc tells you if it's resistant or not. About 50% of the samples for American foul brood that came from Oregon for oxytetracycline were resistant. So, and we have evidence now with European foul brood, there's oxytetracycline resistance there too. The other product, Tylosin or Thailand, is very effective but very persistent in honey. And so you typically need a very long withdrawal. You would not want to do it in the spring because it will make its way into your honey. Okay, so what else can we do? Number one, the fix-all solutions control varroa mites. Varroa mites, especially when it comes to viruses, are key to their spread. Keeping varroa mites under control is key. And they're making holes in the adults and the larvae. Deformed wing cell virus, for those of you who are new, if you looked into your colonies this fall, you may have seen it. It means your varroa mites are high. The second thing is changing your queens. A lot of these diseases have a genetic component. I will say with chalk brood, when I worked in Canada, we would get packages from New Zealand. So in Canada, it was hard to get packages. You still can't get packages from the US, but you can get them from New Zealand. Go figure. And those packages we did a chalk brood study, and we got New Zealand queens, and they always came down with chalk brood in a Canadian climate. Beekeepers typically would just start the package with the New Zealand queens and get Hawaiian queens and substitute them out, and it wouldn't have chalk brood. There's a clear genetic component to a lot of these diseases. So changing the queen, if you have the disease, could help. And one of the traits, you have to take it with it. Old Sol is down in southern Oregon. They do produce hygienic queens, these queens that have a trait that works on brood diseases. But you have to be careful because these are not regulated. We don't know how well they're doing their breeding. And I'm sure they're doing a great job in southern Oregon, but there's no way of kind of checking this. But it has been shown with both chalk brood and American foul brood that if you have a colony, so here the black ones are the hygienic colonies, the white are the non-hygienic. And if you follow, this is a mean score of American foul brood into the first year, and you can see the non-hygienic colonies are going up. And if you come into the next year, the black goes all the way down. You still have American foul brood in the non-hygienic colonies, but the colonies that are hygienic, it gradually goes away. These are bees that have a very keen sense of the smell of a disease larva, and they abort it before it goes to spore, and that's how they break the disease cycle. It works exceedingly well for chalk brood as well. Third is just wait a little. Here is acute paralysis virus that was injected into bees, and you can see it's injected, so we know it's in the bees, and you can see it appears, and then it disappears, and it appears, and then it disappears. Some of these viral diseases come and they go, and if you just wait a little bit, it'll be gone. The fourth one is renew your comb. The comb, I think, is the major reservoir for most of these diseases, and the easiest way to spread it is if you're making nukes or if you're making a split and you're removing infected comb onto healthy bees. This is a study that I did when I was back in Canada. One frame of 1,000 scales of AFB in a colony. If you look at the disease larvae, they go up and up and up and up, and then the colony is dead in September, overwhelmed with American foul brood. So the best thing to do is to get rid of the old comb and exchange it with new comb. And I would tell you that the best time to do that is when your colonies die this winter. And here you can see a nice commercial beekeeping operation where the crew is going through all the dead combs and calling out all the bad stuff. They'll make a pile of comb that's suspect, or as the kids like to say, sus. And then they just scrape it down to the foundation. Just take it all off and then start again. I don't know how effective this is at cleaning off the disease. But I think it probably isn't it probably deals with some of it. So just taking that comb off and forcing them to draw out new comb is a good way to go. And there you can see they've got nice piles underneath where all the old comb goes. So they're constantly renewing and making sure that at least the wax is relatively new. I love this picture for multiple reasons. I think beekeeping in a skirt and pump is a great way to go. But also you can see here's a method that was developed years ago. You have an infected colony here. Like, how do you get all your bees onto new comb? Here's one way. You have an infected colony down here, and you've got a box full of foundation. Foundation is undrawn comb. Okay? You take the first frame here with the queens and brood, and then you put it on top of a board like this so that the bees, the adult bees are, how are we doing this? We got our workforce down here, and they're gonna fly up into this top box as that brood declines and the brood, hatches out. And then this is what she's doing is she's going to then flip it, put a honey crop in here, and then extract it, which I don't think is a great idea to make honeycomb off an old. But you could just retire this old comb after all the brood is hatched out, and then you have a new colony on the top with just one frame of old comb. So that's a really severe way of changing the comb. And comb replacement does work. This is for Eczema disease, and there's all sorts of evidence for other diseases. Here's a colony on old comb over 5 years of replacement. You can see it has lots of Eczema. If you replace the comb in the spring or did something like we saw on that other slide where you replaced all the comb in the fall with this kind of replacement, the disease levels go down. Moses Quimby, the inventor of the smoker, knew this. In the Civil War, he ran this big racket. He was a Quaker, so he wasn't involved in the Civil War, but ran a big honey empire on skep colonies. He noticed that if he had American foul brood, all he needed to do with the skep colony is just junk all the comb, shake the bees out, and have them start again. And that's the shook swarm method you may have heard. You have a disease colony here, you have a box here with foundation. If you shake the bees into that box and let them draw the comb out, the disease often disappears. And I did this in a study with a broken down minivan in the back. And I wanted to find out if you shook bees onto comb, and you did it early in the spring if it had disease, how far would it set them back? I'm very proud of this study because you'll see the honey yields I had. This was in northern Canada. But here are the colonies that were shaken on the foundation. The other option is you burn the colonies and got packages. And then just comparing it to standard wintered colonies. And so after a short period of time, after shaking the bees onto pure foundation and giving them syrup, they were drawing comb. And lo and behold, they didn't make a bad honey crop. So here are the wintered colonies in Alberta, Canada. Yes, folks, that is 300-pound average. Who says I'm the egghead? And I broke it down into the different pull dates. So the first pull was in July, and you can see the different pull dates. What happened with the shaken colonies is there was no honey to pull on the first pull date, but it caught up. And you can see if you worked out, it made a little less honey than the packages, but it more than paid for itself. If you got a package and you looked at the expense of a package, this shaking the bees out was cost effective, and it also got rid of the disease. There are other methods for disinfecting equipment. This is concentrated acetic acid with no glove. This is the old days. But it has been shown as a way to disinfect colonies for Eczema disease, honeybee adult disease. But for the brood diseases, there's really no fumigation that can get rid of it. But you can also torch the box. So you have American foul brood. One of the things you can do is take a tiger torch like this and just melt off all the wax on the surface. This is a great way to reuse the box. What I would do if you did kill a colony from American foul brood, which I do recommend if you have the disease, get rid of all of the comb and then use a tiger torch like this to torch the insides of the box. Okay, pollen is another way to get the disease, and I will say you can buy irradiated pollen, and irradiated pollen is a good idea. So pollen in a pollen patty like this can sometimes include real pollen, and it's really great if it does because it increases the palatability of that patty by a lot. The sterols on the surface of the pollen are super attractive to bees, and suddenly an unattracted patty of protein of yeast and soybean becomes delicious. There was a study though where they looked at the pollen and they looked at colonies that had AFB, and 100% of the colonies of pollen from colonies with AFB had the disease, and 43% of the pollen from apparently healthy colonies had AFB spores. And the significance of this comes in this table, one of the last of the evening. If you, in this old study from 1963, if you fed colonies healthy pollen and you looked at them 16 weeks later, all 3 colonies are healthy. Here, if you fed pollen from an AFB colony in patties, so you didn't infect it at all, you just put you just took the pollen from those infected colonies and made a patty, you see all 3 of them are infected and there's about 31 to 66 cells of EFB. If you took pollen from an AFB colony and then you took a scale and you took a bunch of scales and put it into syrup, it didn't get much worse. So the pollen is a way worse way of infecting a colony than syrup, infected honey or something. The pollen really goes to the larva and spreads the disease. And the worst here was if you took pollen from an AFB colony and then you took scales and put them into the patty, the colony just got destroyed. So really be careful when you're buying pollen. And the 6th thing is really strong colonies can motor through a lot of problems. So keep your colony strong, and if you have weak or severely infected colonies, don't nurse them along, just turf them. Okay, so don't panic. There are some disease-specific treatments. In some cases, like sac brood or chalk brood, you can just wait. Control your varroa mites, requeen with the best selected stock you can find, renew your comb, clean or use irradiated pollen, and weed out the weak colonies, and you should be fine. Okay, hope that was helpful.
That was awesome.